Happy learning! Today we're going to talk about quadratic equations. And so what exactly is a quadratic equation? A quadratic equation in one variable is an equation that can be expressed as ax squared plus bx plus c equals 0. Some number times x squared plus some number times x plus a constant equals 0. Where a, b, and c are constants and a is not equal to 0. Right? If a was 0, this would just be bx plus c, and that'd be a linear equation, not a quadratic equation. Okay, and today we're going to discuss two methods for solving quadratic equations. One is called factoring, and the other one is called the quadratic formula. But before we get to either of those, let me state a theorem. This theorem says if a times b equals 0, so if two numbers multiply to give you 0, then a equals 0 or b equals 0. Okay, might be obvious. The only way two numbers can multiply to be 0 is if at least one of them is 0. But this theorem is going to play a big role in solving quadratic equations. All right, so let's take a look at an example. So let's solve x squared plus 5x plus 4 equals 0. All right, and you might be thinking, what does this theorem have to do with this quadratic equation? Well, it turns out we can write this left-hand side of the equation as a product of two linear expressions. And then if we have this product equals 0, we know at least one of these has to be 0. All right, and so how do we do this? Well, we're going to basically try to undo FOIL. So our first term, x times x, will give us x squared. Now we need to find two numbers that multiply to give us 4, that when we add them together, we get 5. Okay, and so you have to think, it's a little bit of guessing and checking. Two numbers that multiply to give you 4, that when you add them together give you 5, well, that's plus 4 and plus 1. And you can check, if you FOIL this out, x squared plus x plus 4x, that's 5x plus 4. And now we have two numbers that multiply together to give us 0. So it's either the case that the first one is 0 or the second one is 0. So we have x plus 4 equals 0 or x plus 1 equals 0. And this is easy to solve, right? X equals negative 4 or x equals negative 1. All right, and it's as simple as that. Factoring takes a little bit of practice, but basically you need to find two numbers that multiply together to give you c, that add together to give you b. All right, let's look at one more. So let's solve. Six x squared plus 3x equals 4x plus 2. This is a lot tougher, and we're going to see once we talk about the quadratic formula that maybe the quadratic formula is the right approach for this type of problem. But the first thing we should do is we want to bring everything to one side, right? We want to have an equal 0 so we could use our theorem. So let's bring everything to one side. So we have 6x squared minus x minus 2 equals 0. Once we have something equal to 0, now we could factor. If we don't have a 0 on the right-hand side, factoring is a useless thing to do. All right, and so it's a little bit of guessing and checking. We need two numbers to multiply together to give us 6. So we could do 6 and 1 or 3 and 2. So I'm going to try 3 and 2. And then we need two numbers that multiply together to give us -2. And then when we do our FOIL, it would work out to give us -x. All right, and this is a little bit of guessing and checking, so try it on your own. But it works out to be this. All right, I know it's unsatisfying that it is just guessing and checking. But when we get to the quadratic formula, we'll have a technique that works every time. But we could check. So this is 6x squared plus 3x minus 4x. 3x minus 4x is -x. So that's good. And then -2. So it's either the case that this is 0 or this is 0. So we have x equals 2/3 or x equals -1/2. All right, let's look at one more that's not immediately obvious that it's a quadratic formula. So here we have our quadratic equation. So let's say we have x plus 1 over 3x plus 6 equals 3 over x plus 2x plus 6 over x times 3x plus 6. And we want to solve for x. And so the first thing we should do is let's multiply both sides of this equation by a common denominator. Let's get rid of these denominators. All right, so I'm going to multiply by x times 3x plus 6 to both sides of the equation. Okay, and if I'm going too fast, the beauty of YouTube is you could slow the video down. I'll talk in slow motion, but that's okay. You could also pause. Okay, and so on the left-hand side, we're left with x times x plus 1. On the right-hand side, when this term gets distributed to the first term, we're left with 3 times 3x plus 6. And then when it gets distributed to the second term, you just get the numerator because the x would cancel and the 3x plus 6 would cancel. And now we're left with an expression that's a little easier to look at least. Let's distribute everything out. and then we'll reevaluate. So we have x squared plus x equals 9x plus 18 plus 2x plus 6. X squared plus x equals 11x plus 24. How do we deal with this? We need to bring everything to one side. We need to be equal to 0 in order for us to factor. X squared minus 10x minus 24 equals 0. We need two numbers that multiply together to give us negative 12, that when you add them give you negative 10. And so that's multiply to give you negative 24. So negative 12 and 2. So we have that x equals 12 or x equals negative 2. But we need to check our answer because we started with a fraction. It's possible that we divided by x, that one of these solutions results in division by x. So if we sub in x equals 12, this numerator is not going to be 0. This numerator is not going to be 0. This numerator is not going to be 0. So we're good with 12. What happens if we sub in x equals negative 2? I said numerator every time. I meant denominators. So pretend I said denominator. This denominator wasn't 0 for 12. This wasn't 0, this wasn't 0, this wasn't 0. With x equals negative 2, this denominator, 3 times negative 2 is negative 6, plus 6 is 0. This denominator is 0 if we sub in x equals negative 2. That means this is not one of the solutions. X equals 12 is the only solution here. So even though our problem got restated as a quadratic equation, it only had one solution, and that's OK. So maybe factoring isn't your favorite thing. So another way to solve quadratic equations is with what's known as the quadratic formula. And so what does the quadratic formula say? It says if ax squared plus bx plus c equals 0, and a is not equal to 0, then x equals, so to solve for x, which is what we're trying to do, x equals negative b plus or minus, so there's going to be two different solutions here, the square root of b squared minus 4 times a times c all over 2a. All right, so my advice is try to factor at first, and if you're getting stuck and you can't factor, just use the quadratic formula. It's a little bit of a pain to use because there's so many terms, but it will work. It will work every time. So let's solve 2x squared minus 3x minus 6 equals 0. We could try to factor, but let's just use the quadratic formula for practice. So a is 2 in this example, b is negative 3, and c is negative 6. So the solution to this quadratic equation is 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 2 times negative 6, all over 2 times 2. Let's clean up the inside here. 3 plus or minus the square root of 9 plus 48 over 4. And so our answer is x equals 3 plus or minus the square root of 57 over 4. All right, we would not have been able to find this through factoring, or at least not easily. So this is where the quadratic formula comes in handy. All right, what if we have this question? Solve x squared equals x minus 1. Well, first thing we need to do is we need to get everything on one side, right? To use the quadratic formula, it has to be equal to 0. Same with factoring. It has to be equal to 0. So let's bring everything to one side. Now we could try to factor, or we could just use the quadratic formula. I'm going to use the quadratic formula. So x equals, b is negative 1. So 1 plus or minus the square root of b squared, which is negative 1 squared, 1, minus 4 times 1 times 1. So minus 4 over 2. Square root of a negative. You can't be doing that. All right, that is not a real number. So if you get a square root of a negative, no real solutions. So it's possible that a quadratic equation has no real solutions. And in general, it's actually pretty easy to tell if we're going to be in the case where we have 2 solutions, 1 solution, or no solutions. So this value, b squared minus 4ac, is called the discriminant. And the discriminant, so that's the inside of the square root. This will tell us if we have 2 solutions, 1 solution, or no solutions. So if b squared minus 4ac is positive, there are 2 solutions. If b squared minus 4ac is 0, then we're going to have a plus or minus 0. We're going to just be left with 1 solution. And finally, if b squared minus 4ac is less than 0, so if it's negative, well, then we're going to be taking the square root of a negative number, which you can't do, at least with the real numbers. So there are no solutions. All right, so just looking at the discriminant, whether it's positive, negative, or 0, tells us how many solutions there are. And so I want to do a physics problem that uses quadratics. Okay, so a tennis ball is thrown up in the air, and its height function is given by negative 16x squared minus 4x plus 300. where x equals time in seconds. So this tells us the height of the ball after x seconds. And the question is, how long after the ball is thrown was the height (144 feet). All right, so at what time? So we throw the ball up in the air. At some point, it reaches 144 feet. What is that time? So this is actually pretty straightforward. Let's take our height function. We're going to set it equal to 144, and then we're going to solve. So negative 16 x squared minus 4x plus 300 equals 144. First thing we could do, you might think, let's try to use a quadratic formula. Let's try to factor. It has to be equal to 0, so we have to bring this 144 over. So subtracting by 144. And so that's 156 equals 0. And you might notice each term in this, I mean, we're good to use the quadratic formula here, but these numbers are kind of big. So I'm going to divide each term by 4. You could notice each term is divisible by 4. I'm actually going to divide each term by negative 4. So 4x squared plus x minus 39 equals 0. And now go ahead and decide, do you want to factor or do you want to use the quadratic formula? Both are going to work. I'm going to factor, just because why not? But let me know in the comments, are you team factor? Are you team quadratic formula? I predict there will be 0 votes, but that's OK. So let's factor this. This factors into 4x plus 13 times x minus 3 equals 0. 4x times x is 4x squared. 13x minus 12x is x. And then these two multiply to negative 39. So this tells us that x equals negative 13/4 or x equals 3. This says the ball crossed that height in the past. It doesn't make sense in the context of our question. So I'm going to throw this one out, and our answer is after 3 seconds, the ball crosses 140 feet. What it looks like, it looks something like this. So this would be the 3 seconds mark. And if we continued our graph in this direction, that's the other point it crosses. So that doesn't make sense in the context of our question. OK, well, that was our introduction to quadratic equations. We'll be looking at applications soon enough. All right, see you later. Bye-bye.